In example 1, we need to determine if the function is symmetric about the origin, y-axis, x-axis, or line y is equal to x. So let's do the reference first. The reference equation, you're just going to substitute a and b into the original. Remember, f of x is just like y, and b is the y value. And then we'll have 1/2 x, oops, sorry about that. Let's do this down here. That should be a. We're substituting a into the 5th power. So scratch this one up here. The reference, you just substitute those values in where they need to be into the equation. We're now going to look at the origin. The test point for the origin is -a and -b. We're going to compare what happens when we get this point into the function, and we're going to compare it to the reference. So let's try that. We've got -b is equal to 1/2, and then in parentheses -a to the 5th power. Remember that anything that is raised to an odd exponent will have the same sign. The reason why that is because you're going to be multiplying 5 negative a's together, and 2 negatives make a positive, another 2 negatives make a positive, and you'll have that negative left over. So the negative value here raised to the 5th power, or any odd exponent for that matter, is going to be negative. So this is times -a to the 5th. I can now divide by -1, and I'll have b is equal to 1/2 a to the 5th power. This is exactly the same as the reference. So we can say, yes, that there is symmetry about the origin. You can also look at the graph and notice that around the origin, if you were to rotate this graph, this piece would line up exactly on this other piece, and this piece would line up exactly on that piece. Let's try the y-axis. So the test point for the y-axis is going to be -a comma b. We're going to plug that into our equation, and we'll use parentheses here. Remember that that negative sign can come out to the front here. I didn't do that on the left-hand side, but you can move that out to the front if you'd like. We just have a to the 5th. This is different than this equation, the reference equation, and we can't get it to look like this one. If we divided by -1 or multiplied by -1 on each side, then we'd have b is equal to 1/2 a to the 5th, which is still not this. We'd just be trading negative signs back and forth if we kept multiplying by -1. So there's no way to make this right here look like that. The answer is no. And you can see also with the y-axis being here, if you flipped the graph to the other side here over the y-axis, then this piece would be down here and it wouldn't line up on this top part. So this graph is not a reflection of itself over the y-axis. Let's try another one. So we'll do maybe the x-axis down here. So the x-axis test point is going to be a comma -b. We'll plug that into the equation. So we've got -b is equal to 1/2 a to the 5th power. That's -b is equal to 1/2 a to the 5th power. Notice if we divide by -1, we're going to have the same setup right here. And there's no way for us to adjust this equation to make it look like the reference. So our response here would be no, it's not symmetric about the x-axis. One last one to do. We're going to try the line y is equal to x. The test is b comma a. So this time the a is going to be the y, and the b will be the x. So we'll be left with a is equal to 1/2 b to the 5th. Even though these look similar, the a and the b are in different spots, and so we can conclude that there isn't any symmetry about the line y is equal to x. You could try to solve for b here. You'd have to multiply by 2, so you'd have like a 2a, and that would be equal to b to the 5th. Then you could take the 5th root of each side, and you'd have b is equal to the 5th root of 2a, but that still doesn't look like this one. So you can mess around with this algebraically as much as you want, but you're not going to get it to look like, oops, that's off the screen. You're not going to get it to look like the original reference equation right up here. That's really it for this. It's symmetric about the origin, not any one of these other ones. Algebraically, we've shown that, and we can also see that on the graph.